Alright, so this video is meant for my Concepts of Algebra 2 students. We have a quiz on Tuesday. Sadly, it's the last quiz for my seniors in the class, but so we're going to go out with a bang. So here's a review. Hopefully you pay attention, take the notes, bring them to class, and you do awesome on the last quiz and really help your grade out. So we're going to start with some composition of functions. Alright, so I've given you three functions here. F of x is 3x squared, g of x is x squared plus 5, and h of x is x minus 4. We're just going to go through and do about 4 composition of functions. The first one is f of h of x. So here's how we're going to approach this problem. Remember, it's always inside, out. We start with what h is. H is x minus 4. Replace f of x minus 4. Okay, and now I'm going to write down the function f because that's the only thing left. F is left. F says 3x squared. I'm going to write 3 parentheses space squared. So I did not write the x. Remember, you leave out the x, and in that space goes the other function, x minus 4. There. Okay, so now to simplify this on the side here, I'm going to rewrite x minus 4 twice because that's what x minus 4 squared means. And we're going to FOIL first x squared, outer minus 4x, inner minus 4x, and the last. Negative 4 times negative 4 is positive 16. So we can simplify the middle terms. X squared minus 4 is minus 8x plus 16. So this right here, there is a 3 still out in front that must be distributed. So 3 times, and then what we got when we squared the x minus 4, x squared minus 8x plus 16. And now we're going to go ahead and distribute that 3 to simplify the final answer of 3x squared minus 24x plus 48. Okay, there's the first composition of functions. Okay, next one we'll take a look at is h of g of x. Okay, so again, it's always inside out. Inside out. Replace g with what it is. So we're going to say h of, and g is x squared plus 5. So now h is the only function I have left. So I'm going to write down h. H is x minus 4. X minus 4. Notice I don't put the x. I leave a parenthesis space, and in that parenthesis goes your x squared plus 5. Now, if there was a number in front of the parentheses, I would distribute. If there was a power, I would rewrite it that many times. But there is nothing, so these parentheses don't matter. So this problem is just x squared plus 5 minus 4. And the only thing I can simplify is the plus 5 minus 4. So it's x squared 5 minus 4 is 1. All right, one more of these. Okay, let's do a function into itself. F of x. Okay, so in this problem, we're going to take f and plug it into f. So we're going to rewrite the inside f first. So f of, and the inside f is 3x squared. Now we have this outside f left, so I'm going to rewrite that 3x squared. Notice I leave the x out, right? And I'm going to put this in its place, the 3x squared. And it's kind of weird because it's, a function of itself. That's okay. So now we have to do this exponent first. There's the 3 out in front and the squared outside the parentheses. You have to do the squared first. Well, over here, 3x squared means 3 squared and x squared squared, which means 9, and when you square squared, you times. 2 times 2. 2 times 2 is 4, and that's the exponent, 4. So this 3x squared squared is 9x to the 4th. So this right here is 9x to the 4th with the 3 out in front. 3 parenthesis 9x to the 4th. And now we just multiply 3 times 9, and 3 times 9 is 27x to the 4th. So there's a situation for your composition of functions. Make sure you use the right functions, and inside out, inside out, inside out. Okay, so here's our problem here. So it says that a store, or you have a coupon for $20 off a pair of shoes. The store is also offering a 15% discount off the price. So there's two discounts going on. There's a coupon and there's a percentage discount. So first, let's create f of x. Create f of x with coupon only. All right. So what this means is we have to take the price and work with the coupon. Well, the coupon says $20 off. That's the coupon. So we're going to take our function f of x, which represents the cost that you're going to get, the cost. And we're going to take the price of the shoes x, and we're going to take $20 off. And there's our function f. B says create the function g of x with the 15% only. With the 15% discount only. Okay? So now we're looking at this right here, the 15% off. Well, remember, you have to do this kind of on the scratch work. You pay 100%, but you're getting 15% off. So that means you're paying 85% of the shoe. Okay, the shoes. So your function g of x represents your cost, and your cost is that 85%. 0.85x. Okay? So that's your cost. So now I want to create the two compositions of functions. So let's do the two compositions. So let's start with, we'll start with f of g of x. So we always start inside out, right? So f of, and then g is 0.85x. So what this function's representing, this composition, is we are going to apply the 15% first. So this is the 15% first. Okay, that's this one. So now we have, the only function is f, so we replace f with what it is, x minus 20. And in that place of x, we put the 0.85x. And there's no number in front of the parentheses, no exponent of the parentheses. We drop the parentheses and we get our answer of 0.85x minus 20. So that is if we use the 15% first. Okay, so now let's do the other composition. G of f of x. Inside out. G of, and f is x minus 20. So this is the coupon first. Right, the $20 off first, because that's the inside function. Well, g is 0.85x. So we write g, 0.85x. And in that place where we don't write x, we put x minus 20, the other function. So now we have to distribute. So we get 0.85x. And my calculator says that 0.85 times 20 is 17. Okay. So now let's talk about what is advantageous for me. What, as a consumer, what would I want? Well, if we use the 15% first, I pay 85% of the price minus $20. If I use the coupon first, I pay 85% of the price minus $17. So I want more taken off. So this right here, this one is better for me. So what I would want, I want the 15% off first. Because I save, and I save, there's a difference of $3. And in this world, I want to save any penny I can get, even if it's just $3. Okay? That's important to me. Okay? So that's what I would want as the consumer. I want the 15% off first because they take away $3 extra from the price. There's how we do the real life example of composition of functions. Okay, so now we'll do a couple inverse function problems. Find the inverse function. And we'll start here with A. A says f of x equals 2/3 x minus 6. Well, we have to remember how to do these inverse functions. So it's a two-step process. First, I don't want f of x, I want y. And then I want to take x and y and I want to swap them. I want them to change places. So now it's not going to say y equals. It's now going to say x equals 2/3 y minus 6. And now I need to solve this for y so that it does say y equals. So I have a 2/3 and a minus 6 to get rid of. Let's add 6 to both sides to get rid of that 6. Remember, this does not combine. It's just x plus 6. And on the right here, we're going to do 2/3 y, leave that alone, and the 6's go away. And now I need to get rid of this 2/3. Now, it is 2/3 times y. So you could divide by 2/3, but I told you in class that's hard. So instead of dividing by 2/3, let's multiply by the reciprocal, 3/2. So times 2/3 y by 3/2 and times this side by 3/2, the reciprocal. And remember, this x plus 6, there are two things there you better put in parentheses because of that plus sign. Distribute the 3/2 to the x and to the 6. Now this 6 is 6 over 1. So 3 times 6 is 18. 2 times 1 is 2. On the right side, 2 cancels, 3 cancels, and we get y. Now, I think that 18 over 2 can be simplified. 18 over 2 is just the number 9. So now I can rewrite it with just only one fraction, the 3/2. So in place of y, I use my notation. F inverse of x equals, and we have 3/2 x plus 9. There's our first inverse function problem. Okay, so here's our next one. Let's try to find the inverse of f of x equals the 5th root of 2x. All right. So in order to do this problem, okay, again, same process. Make f of x y and switch x and y. So now it says x equals the 5th root of 2y. Well, I want to solve this for y now. Now, you see this y is inside that 5th root? That stinks. Because you can't bring the y outside the 5th root. That 5th root has to disappear. So if you remember solving these radical equations, if it has a 5th root, to get rid of the 5th root, we can raise it to the 5th power, the nth power. And if we do it to the right side, we have to do it to the left side. So now we're going to have x to the 5th equals, and over here, the 5th root and the 5th power cancel, and there's my 2y. How about that? And now to get y by itself, let's divide by 2. So we have x to the 5th over 2 equals y, because the 2's cancel, and now I replace y with f inverse of x. F inverse of x equals x to the 5th over 2. And there's the inverse of the 5th root of 2x. Okay, so that's finding an inverse. Okay, so now we're going to verify that f and g are inverses. And if you might have seen this, this is the question 3 part A, this f of x. So I just took f of x, which was the 2/3 x minus 6, and its inverse, which we found, was 3x or 3 over 2x plus 9, and I just called it g of x. So now we're going to verify that these are inverses. So again, we found them up above in number 3 part A, but now let's verify them. So there's two parts. The first part, f of g of x. Okay, I want to not that. Give me 1 second. I want to make this just there you go. F of g of x. This is the first thing we have to do. Let's go that way. Well, it's inside out. F of, and our g is 3/2 x plus 9. So now I'm going to write down f of x. 2/3 x minus 6. And in that spot where I had the x, I'm going to put this 3/2 x plus 9. And now it's our job to simplify. Well, guess what 2/3 times 3/2 is? The 2's cancel, 3's cancel. It's just 1. If you want to multiply it across, you get 6 over 6, and 6 over 6 cancel. Okay? But now, you have to still distribute the 2/3 to the 9. Now put the 9 over 1. 2 times 9 is 18. 3 times 1 is 3. And then the minus 6 comes because it was outside the parentheses. So that's 2/3 times 9 is 18/3. But look here. The x comes. 18 over 3 is 6. So it says x plus 6 minus 6. Bye-bye, plus and minus 6. Hello, x. And there's the first part, f of g of x. Now, you must do the second part, the reverse order, g of f of x. Inside out. G of and f is 2/3 x minus 6. So this is going to be g, which is 3/2 x plus 9. And in that spot where x is, I'm going to put the 2/3 x minus 6. So again, it's distribution. Again, the 3/2 and the 2/3 cancel and give you x. Again, if you want to put 6 over 6 and then you cancel and get 1, that's fine. And now we have to do 3/2 times 6. We'll put the 6 over 1. It's going to be a negative because the 6 is negative. 3 times 6 is 18. 2 times 1 is 2. So that's 18 over 2. And then the plus 9 comes after. Well, 18 divided by 2 is 9. So it's x minus 9 plus 9. X minus 9 plus 9. Cancel out those 9s. There's my x. And that's verifying that two functions are inverses. So we should feel good about number 3, part A, that we found the correct inverse because they did verify out. Okay, so here's our last problem. It's going to be a word problem to find an inverse. So it's this fitness. Elastic bands can be stretched excuse me, when exercising to provide resistance. All right, so you guys have hopefully if you've exercised, you used the bands before, jump, stretch, whatnot. A band's resistance, R in pounds, can be modeled by R equals 3/8 L minus 5, where L is the total length of the stretched band in inches. So I'm going to write the inverse. So right now, in this problem, we talked about R, the variable by itself is the output, and L is the input. Well, we want those to switch places. We want the L to be alone. So what I'm going to do is I'm going to take this equation, R equals 3/8 L minus 5, and I'm going to solve for L. Okay? So the first thing I'll do is I'll add 5 to both sides. R plus 5 equals 3/8 L. And then remember, you could divide by 3/8, but instead multiply both sides by 8/3. And over here, R plus 5 goes in a parenthesis. So we're going to distribute the 8/3, and we'll get 8/3 R plus, and now this 5, put it over a 1 and multiply straight across. 5 times 8 is 40. 3 times 1 is 3. Okay? So this is going to equal, so that's the left side, and 3/8 and the 8/3 cancel, and there's L. So if I put L first, my equation is L equals 8/3 R plus 40/3. So there's the equation we're going to use. And now we are going to find the length if the resistance is 19 pounds. So now R is going to be 19. So we're going to plug it into my formula up there. L equals 8/3 times 19 plus 40/3. And I think it comes out to be a nice number, I hope. Checking the calculator, 8/3 times 19 plus 40/3. Yes, perfect. And it comes out to be 64 is what I got. 64. So again, use your ABC button, and you get 64, and the label is inches because that's what length is. Length, stretch band in inches. So if the resistance is 19 pounds, that means your elastic band is stretched out 64 inches. And if you think about feet, 64 inches is 60 inches is 5 feet. So that's pretty far. All right, that's pretty far. So there we go. Okay, so that's finding an inverse in a word problem. And again, notice we did not switch L and R. We just simply solved for L so that L was by itself. Okay, a little bit different than those X and Y problems. Alright, so hopefully this all made sense to you and you come in Tuesday ready to go for this quiz. Alright, thanks for watching.